Okay, is my presentation visible to all of you?
Yeah,
Yes.
yeah, we can see.
Okay, so great. So I think many of you are working as a piping engineer. So we know that in a piping department, we have three subgroups. The larger subgroup is a piping layout, larger in the sense the number of engineers working in one project. So in piping department, we have three subgroups. First is a piping layout. Second, piping material engineer. And third, piping stress analysis engineer. So in market, many of us, when we talk about the piping engineer, many of us are just talking about the piping layout engineer from modeling point of view. But at the same time, we do have two different departments: piping material engineer and piping stress analysis engineer. And I think these two groups are considered as a core group of a piping, because it's purely on a technical knowledge they work. So today we are going to have an overview of the activities carried out by a piping material engineer, as well as a few aspects of piping specification or the piping material, we can say. Okay, so I'll start with the session. If you guys have any questions, we will take at the end of the session. Yeah.
हाँ लागला
Okay.
ठेव चंद्र बोल
Okay. So what is a piping material engineer? So as we all know, anyways, we all are working. Okay, I'm sorry if few things are very common and at the basic level, because this session is targeted for everyone. So there might be a fresh college graduate student who have no idea about the piping, as well as there are just the junior engineers who have started in this industry. So I have included a few basic concepts also. So this might be repetitive for this, but being a larger audience, we have to, make the common content for this presentation. So as we all know that piping does not means only a pipes. It also includes the other components like fitting, flanges, wall, bolt, gasket, special parts. So the combination of all these piping components make a piping system. So what is the role of a piping material engineer? So piping material engineer is responsible for quality of a material, creating a project pipe classes and various piping specification required in the project too. So why to create all these documents? So these documents are required to fabricate and test the piping system. If I want to build something, I should know from where I should build it. And once I build it, I have to test it whether it will be running as per the expectation or from the quality point of view, whether it's running or not. So that's why the testing is important. So in few companies call this position as a piping material engineer. Few companies call this position as a piping specification engineer. So as I told you, so when we say about the piping layout engineer, he mainly deals with the 3D modeling software like E3D. Previously, it was known as PDMS or S3D or different softwares. So there, the task of piping layout engineer is to route a line from one location to another location. But the pipe which is selected to route from one location to another location, it has to be of certain material, certain quality, certain requirements. Now, how should I know that which material I should know, why I should use, or what testing shall I apply on those material after I use, so that that material is suitable for the selected application. So there should be some guidelines, right? Everyone cannot follow their own guidelines. That is why we do have some global guidelines, and then we have some global institutions. They have created few codes and standards. So certain rules are mentioned in those documents. So in the engineering we do follow these documents so that we all are following some quality standards. So there are two terms. One is a code, another is a standard. So by definition, code is a group of general rules or systematic procedures for design, fabrication, installation, and inspection that are adopted by legal jurisdiction and made into law. So as I said, for the quality purpose, we have to follow something, and these are quality documents prepared by some agencies. Okay, so these are the set of rules and requirements which are the minimum requirement to be followed. Features in the covers in the codes. So general guidelines for the design, minimum engineering requirement for the safe design, and they indicate the reference standards. To give an example, everyone, the people who are working in the piping industry, they must have heard about the ASME B31.3. So generally, this standard we use for our chemical industry. So in that standard, so many different and as well as the complicated rules or the regulations are given that we have to follow when we prepare a piping material specification. Then we have a standard. So these standards are a document prepared by professional societies or committee which are believed to be efficient engineering practice and which contain mandatory requirements. So when we say that which are believed to be efficient engineering practices, so while before publishing this such documents, they have done a lot of research and development, a lot of testing, and then set some rules that if these rules are followed, then this material or this component is safe to use. So these are the additional requirement to the course. Okay, so at this moment, I will not go into too much of this because I know this is a complete theoretical portion, and frankly speaking, this has to be covered in a deep details. So obvious, in a short time, this is not possible to go in this standard, and just by giving something on the slide, it is not possible to explain also. But just to give an idea, there are two things, codes and standard, which gives some rules and regulations to prepare our documents, so the specification documents. So what are the advantage of working with codes and standard? Why we have to follow this? So they establish a commonality in engineering criteria, terms, principle, practices, materials, and process. So when I say about commonality, okay, so now as we know that if someone has the Apple phone, okay, their mobile charger is different, and if someone is using some another company Android phone, their mobile charger is different. So you cannot connect. So if Android person want to connect a charger, he cannot take it from the user of the Apple mobile. So there we do not have any commonalities. And why sometimes this commonality is important? Because all over the globe you cannot set different set of rules or something. There are different rules, but majorly the standards which are followed are the American standards, which is the ASME standard. They help to establish a standard way of working. So whether the project is getting executed in India, or if it's getting executed in Saudi, or if it's executed in US or Europe. If you follow a same standard, global accepted standard, you have a standard way of working. They ensure build in safety, reliability, and continuity. So We must have observed that there are a few cases of accidents, blast happen in the chemical industries, be it a chemical plant, small, big, catching of a fire for some equipment, the blast of the boiler. There are some serious accidents happen in the past, and unfortunately now also the few accidents are getting happened. So that is why the safety is important, and these codes and standard has put some minimum requirements. So if you follow those requirements, the safety of your system will be taken care. Just to give an example, um, uh, now we select a pipe. Okay, then what should be the thickness of that pipe? So there is one formula given in the code ASME B31.3. Based on that formula, we have to calculate a thickness. So in that formula, there are multiple factors like allowable stresses. So they have given, if you select a carbon steel pipe, then at this temperature, this will be the allowable stress, because they have done already the testing of the materials. So if we follow those values, those rules, then our pipe is suitable for XYZ design pressure and temperature. They minimize mismatches and promote interchangeability. So as I said, the mobile charger of Apple and another Android phone cannot be interchanged. Sometimes interchangeability is also important. They economize the system, reduce inventory, and ensure readily available backup from the market. So when all over the globe you are using the same material, and if you suppose you build a plant now, after 10 years you want to buy some part, some pipes or some walls, so it should be available in the market. It's like when we buy any four-wheeler, any car, we always check what is the possibility to get the spare parts in the market. Unfortunately, if something is broken out, then and you have to wait for the spare part to be ordered from some another country, which will take 6 months or 8 months. Nobody would like to do that. Those spare parts should be available just next to you immediately. So that's what our expectations are. They help in accumulation of knowledge. They help in avoiding reinventing the wheel again. So as I said, when some standards and some codes are published, they are published with a lot of backup, a lot of research, which is already done. And what we have to do as an engineer, we just have to follow those standards. We do not have to do any research or analysis, nothing. The certain rules are given and we have to follow that. And that's good for everyone. So as I said, interchangeability or the set of rules. The people who are seeing these, the people who are seeing this chart for the very first time, they might get confused. You don't know, you don't have to remember everything, but I will just explain you the first row as an introduction. Going into details of this it will take a lot of time, and this is not intention of our today's session also. So in general, we have the different materials like carbon steel, alloy steel, high temperature, alloy steel, low temperature, and the austenitic stainless steel. We do have another categories, but these are the majorly used. So for example, let us take an example of a Samsung mobile. If I want to buy a Samsung mobile, I do not go to a shop and say that, okay, give me a Samsung mobile. I don't say that. I ask them for the specific version, or like I want A34. I want Samsung A34. I want Samsung M52. Okay. Or you also have the series, S series, M series, A series. So you go and tell him the specific product that you want to buy. On a similar basis, if I want to buy, so this is example of different components used in piping. So let us take an example of only pipe. So if I want to buy a pipe from a market, carbon steel pipe. So I don't go to a vendor and say I want a carbon steel pipe. Okay. In general, when you want to use something at your home for the basic use, it's okay. But when you are using a product in the chemical industry, which is dependent on so many different factors, you have to be specific. So that is why, again, these are the global standard, ASTM standard, American Society of Testing and Materials. They have given some names or the tags to the certain materials. So if I want to buy a carbon steel pipe, it is called as A, it means ASTM 106. This is some number they have given. Grade ABC, that depends on your the chemical composition of that material. So if I want to buy a stainless steel pipe, okay, then the main grade is ASTM A312. Main ASTM standard is A312. Within that, we do have a multiple grades: TP304, TP316, TP321, TP347. So just to give an idea, this is, I mean, if we add the molybdenum in TP304, it becomes TP316. And TP316 has a higher corrosion resistance property as compared to TP304. So this is how these materials are distinguished and called by certain names. Okay. Okay, I have to come to this part later on, but okay, now I'll select two. I know I think I'll come to this slide later on. So in general, if you want to see the material of construction, which are the materials which are used in a piping. So the main three categories are the metallic pipe, non-metallic pipe, and the lined pipe. In the metal also we have a ferrous and non-ferrous. Okay. Uh, I'm sorry. This non-ferrous should be copper and nickel alloy should be here. I by mistakenly put it there. Uh, so in ferrous we have a cast iron, carbon steel, alloy steel, and stainless steel. When to use this, uh, it has to be explained in a detailed way. Non-ferrous comes copper alloy, nickel alloy, and other alloy. And in the non-metal, you have. I'm sorry, this three should under this non-ferrous. I by mistakenly put it here. In non-metal, you have plastic pipe, GRP pipe, glass reinforced pipe, FRP pipe, fiber reinforcement pipe. To give an example of plastic pipe, generally nowadays in a sanitary piping in our bathrooms, we use a white PVC pipe that you must have seen. But in the older days, there was no PVC pipe. They used to use a galvanized pipe, galvanized iron GI pipe, what they used to call. And also we do have a lined pipe. Okay, I will show you one of the photo for this. So what is the lined pipe? It is nothing but a metallic pipe, just common metallic pipe, but from inside some different material lining is given. That lining may be of the rubber or the PTFE. It depends on the application what we are using. Okay. So I mean, while continuing this session, I will try to show a few images or the few things from the Google, because if I just explain the things from the slide, it might get boring, and it is also not possible. I don't like to put everything on a slide and then just edit it out. A few times I'll go to Google and show you the images also. Now we have seen there are different type of materials which are available in the market. But when to use which material? I mean, what are the criteria to select a material? So, for example, if I want to buy a camera, then first I decide what is my purpose. It is just for my hobby, or whether I have to click the photos when I go to for a vacation, or whether I have to click some nature photos, whether I have to do some professional photo shooting or something like that. So first we decide the criteria, why I want to, for what purpose I want to buy the camera. That purpose should be known while selecting anything, be it your day-to-day life or be it a piping engineering. So selection of a correct material is crucial and it depends on various factors. So selection is obviously important. If I want to do a professional photography, I cannot use a basic camera. Okay. So selection of a correct material is important. So on which factors this correct material is depend. So the first most important is a type of a fluid. The type of a fluid which is flowing through the pipe or the piping system. So as we know, it is not on a pipe. The fluid flows to the pipe, elbows, fittings, walls, everything. So the type of the fluid, temperature of the fluid, and cost and availability in the market. So as I say, type of the fluid. So if it is a normal water, you can go for the carbon steel also. But if some fluid is very highly corrosive, then you cannot go for the carbon steel. You have to go for the stainless steel. Then also the fluid temperature. Then this slide will help you. So when I'm using, so for example, one of my fluid is suitable for the carbon steel as well as for the stainless steel. It is suitable for carbon steel also. It is suitable for stainless steel also. Can I use stainless steel or can I use carbon steel? So here then you have maximum temperature also which you have to take care. You can use the carbon steel till 800 degree Fahrenheit. Generally 427 degrees Celsius we use carbon steel. Above that we go for the alloy materials P11, P12, P22, P91. Okay? And if these are the maximum temperatures. So this H means it's used for the higher temperatures. And also we have to think about the cost and availability in the market. So as I said, water can be carried out in a carbon steel pipe and also it can be carried out in a stainless steel pipe also. But then I can select the stainless steel pipe from suitability point of view. But when it comes to a cost point of view, I have to select a carbon steel because carbon steel is cheaper than a stainless steel. So, as I said, the corrosion resistant material is required for corrosive fluids like seawater, acid, etc. Whereas for air, water, or normal carbon steel can be used. As I said, general till 425 degrees Celsius or till 427 degrees Celsius, we can use for the carbon steel. If the temperature goes beyond that, then we have to use the alloy steel. What are the alloy steel? Alloy steel is nothing but addition of few alloys in the material which enhances the chemical and the physical properties of that material. And as I give you example of the water for the carbon steel and stainless steel pipe, selected material should not be always of the more superior quality. Otherwise, that will lead to a higher cost. So we have to be careful about this also, not always to select the superior material, but we also have to, optimize the cost also. So before going into detail, I would like to just highlight the which are the type of the components used. But I think many of you are already working in piping industry, so maybe everybody knows these components. Hope my voice is clear, or is it low?
It is clear.
Okay, great. So, type of components. As we know, the pipes which are used to transport a fluid from one point to another point. Then we do have some components called as the fittings, which are the 90-degree, 45-degree elbow. These are used to change the direction of the fluid by 90-degree or 45. Then we also have the concentric and eccentric reducers. If you want to reduce the size of the pipe, I mean, the people who are not working in the piping industry, for them, the example could be a pipe which is coming in your apartment. There is a water tank at the on your terrace of your apartment. So from the terrace, there is one pipe which distributes the water to each apartment floor wise. So if you see carefully, for the first few top floors, the pipe diameter is big. Then the pipe diameter gets reduced step by step. And how that is reduced? By connecting the reducers. Now, where to use the concentric, where to use eccentric, that's another part. If you want to take the branch connection, equal and reducing T. If you want to end the pipe, then it's cap. So main is pipe, another is a fitting. Then we have a valves. So I have not listed all the type of the valves, but the basic valves which are generally used is a gate valve, globe valve, swing check valve, butterfly valve, ball valve, and a plug valve. So mainly, so again, uh, I have a next slide. Yeah, so I'll go back to that slide afterwards. So as I said, which material to be used depends on so different factors. On a similar basis, which valve to be used, it depends on its function. So for the isolation, it means whether to stop the flow, completely stop the flow, or to completely start the flow. We have an isolation valve. So what are the different isolation valves? Gate valve, ball valve, plug valve, piston, diaphragm, butterfly, pinch. Getting into detail of the valve, one valve we can explain it in very detail, but due to the short of time, it's not possible to explain everything today. But as I said, it is just an overview. Then we have a regulation valve. Sometimes we don't have to close the valve completely. We have to regulate the flow. Then we can use these type of valves. Okay. Gate valve cannot be used for the regulation because of its structure. Non-return valve. It means a check valve because sometimes we do not want the fluid is flowing from left to right, but then we do not want that fluid to get back from right side to left side. You know, in such cases we use the check wall, and then we have a different type of check wall: lift check wall, sink check wall, dual plate check wall. Okay, and then there are some special purpose wall. So as you see for the isolation, so if you see a document piping material specification, the may in most of the case 95% I'll say the isolation wall which is used is a gate wall. Then for the regulating purpose, we do have a globe wall. And then we have a swing check valve where we don't want the flow to go back. So like in this case, the flow is coming from here. If it comes from here, it will lift this disc because it is attached to this hinge. And when there's a flow stops due to the gravity and weight of this disc will sit here and it will close the flow. Then we do have a butterfly valve. Sometimes for the cooling water lines or the big lines, the 40-inch lines, there we do not want to go for the gate valve because that assembly will be very huge. So in such cases, we use the butterfly valves. Then we have a ball holes in certain applications. As isolation, gate valve cannot be used. So there, then we go for the ball valve, or sometimes we go for the plug valve also. And in this slide, when I told you about the lined, so now if you take an example of PTF lined, so here you can see this is the metal part, okay, and this white portion is nothing but a PTF lining. So similarly, you will find a pipes and the fittings also, which has a lining from inside. Then we have a next component called as gasket. Again, in gasket, we have so many different types. The flattering gasket, full face gasket, spiral wound gasket. Generally, we use the spiral wound gasket. Yeah. Here, if you see the outer portion, this is made of stainless steel SS316L. It's mentioned here. This inner portion is also made of SS316. And this middle portion is made of some soft material. Sometimes it's made of the graphite, sometimes it's made of the PTFE. And as I said, when to use graphite, when to use PTFE. PTFE can be used till only temperature 220 degrees Celsius or 240 degrees Celsius. But for the general purpose, we use this is spiral wound gasket. So we say the spiral wound gasket with SS316L and a graphite feeler. So it means this in the middle portion with the graphite. But sometimes the fluid is not suitable for the graphite. Then we have to change this filler. Then we change this to PTFE. Then we have a bolts of the stud bolt with nuts, hexagonal headboards. Then we do have some special parts like a stem traps. Then we have a Y-type strainer. This Y-type strainer is generally used before the pumps, so that pumps or the compressors, so that the impurities in the sense the physical impurities, the particles are not transported to the pumps or the compressor and it is not damaged. So it has some mesh or the straining, you will say the fluid will go from here, the particles will stay trapped here and only the clean fluid will be passed here and then it goes through the pumps. Then we have the expansion bellows. It's based on the stress analysis. These expansion bellows are recommended. So in general, okay. So before that, I would like to show something. Yeah. So here, if you could see, like in this image, the outer portion is a normal metallic pipe, but just from the inside, we have given a coating. I'll not say so. It is not a coating. It is a lining. It's a lining of the PTFE material. So generally for the acids or the fluids which are very corrosive, we can use these PTFE lined pipings. And as I said about the globe wall, So I'll say a globe wall and a gate wall. So if you see a structure here, this is a disc. So when you, this is a hand wheel, when you turn a hand wheel, this portion will go upside and this is a portion which is closing this flow. So it will also move upside. But in case of the globe wall, see the construction is a little bit different. It is the flow is not a straight flow. It will go down, it will come upward, and then it will flow from here. So in this case, we cannot use this for the regulating purpose because then if we keep this disc half opened, your fluid will be continuously hitting this disc. But in case of the globe wall, which when this handle is rotated, this disc or the closing portion from here, it will go to this portion and the fluid will flow from this outlet. If you open it more, the more fluid will flow. Yeah. Then we have this ball wall. Here you can see a little small ball is there. That's why it is called as a ball wall. And this is the opening. So fluid will come from here and go from there. And when you rotate this ball, this closed portion will be on this side and your flow cannot go ahead. So details of these walls cannot be explained today. All these details we will see in the our detail sessions, but this is just an overview session. Yeah. So so as everyone I know I work as a piping material engineer for so many years. Then as I said, everyone just talks about the piping layout engineer or the modeling engineer, but the piping material engineer role is very important in a piping department. And even from the career perspective, uh, it has a very bright future. Frankly speaking, it is difficult to get the piping material engineers in the market. It's very because it's a core group. You are a specialized person as a piping material engineer, and you gain the knowledge of the piping material engineer only by the experience. You should have a several years of, even if you have a several years of experience, you will learn so many things every now and then because new technology is coming up, new material is coming up. Sometimes few vendors develop their own materials to increase the temperature limit also. So we have to be up to date with the market also. So as from career point of view, this is a very good career also, I'll say. Even if you see in the job market, there are a lot of opportunities for the piping material engineers. And it is one of the very core group, I'll say. So what is a piping material engineer? The piping material engineer is required from bid stage through design, construction, and mechanical completion. So in all phases of the project, you need a piping material engineer. It is not for the short term of the project. So when I say at the bid stage, what is a bid stage? For example, a client want to set up a plant, okay, and then he want to know what is the cost of that plant. So as a EPC consultant, I have to give some cost to a client that if you want to build this plant, this is a cost. Now, how a plant will be built? You need some material, build that plant. You need some construction efforts. You need some designing efforts. Okay. So one of the major part is the procurement of the material. For example, if you want to build a building, let us take an analogy of building a building a building, apartment, or your own house. So major cost will be from the material which is required to build that house, be it a bricks, be it a sand, be it a cement, be it a color, be it your steel, anything. Then, as we say that for certain fluid, certain material is suitable up to certain temperature and so and so. So accordingly, in the bid stage, what are the fluids, what are the chemicals included in that plant? Accordingly, we select a correct pipe material or the material or we prepare the piping classes. Then we take out the bill of material that if I want to buy a house, how much how much cement I require. I do have an estimate. Okay. So accordingly, we give this estimate to the client. So at this stage, the role of piping material engineer plays. Sometimes, as I said, the cost is important. I cannot always select a superior material. So as a piping material engineer, I have to select a proper material so that cost is not escalated. It is always within a budget and client will be positive that okay, I can build this plant. Then through main detail design phase, the construction phase and the completion phase. Review the client's technical documentation and requirements. So for example, if I want to build a house and I have given my work to certain construction agency or the interior, you will say, okay, let us take an example of the interior of your home. If I do the interior of my house, I have some certain requirements that I want my living room to be colored in this color. I want my hall to be colored in this color. I want the position of my wardrobe like this. I want the kitchen in this color, these many trolleys, these many cabinets. I want my stove on this side. I want my wash basin on this side. I want this equipments. So as a client, I have some requirements which are some of my expectations. So similarly, in the EPC industry, I will not say just an expectation, but client has also set up some it's his own rules and regulations, what he wants. So I have to then he gives those documents to EPC consultant. Then out of that, the whichever part is required for the piping material engineer, I will review those documents. If I want some deviations to be taken for this document, then I will tell client that you have this XYZ requirement. However, we cannot fulfill this requirement. Can we go ahead with this ABC plan? So this is a deviation. Then client said, okay, yeah, you can go with this plan. So first we have to review the documents which client has given from piping material point of view and not from the overall engineering point of view. Then, in the designing part, what are the main responsibilities of a piping material engineer? The first part is to perform the wall thickness calculation. So it's like, okay, I have to buy a pipe from the market, but then that pipe will have some certain thickness. I cannot use a too high thickness pipe or I cannot use too thin pipe. So how this pipe wall thickness getting calculated? So again, I don't like to put everything in the screen. I'll go to Google and pipe. I will not sure. I will not go into the detail of this. So generally, our plans are based on ASME B 31.3. And as I said, this is yeah. This is the formula for the pipe wall thickness. So T is nothing but a thickness of a pipe. So if I want to design a pipe or any component, then I know that which fluid is flowing through that pipe. Then if I know which fluid is flowing, then I also know the design pressure and the design temperature of that fluid. So P is a design pressure. Why pressure is important? Because I should know that whether that pressure is whether the thickness is can sustain that pressure or not. Then D is the diameter of that pipe, selected pipe. S is allowable stress value, which is taken from ASME B30.3. For example, if I am taking a carbon steel material, which is ASTM A106 grade B, which is generally used, then I'll go into that standard. I'll see what is the value allowable stress value given in is given in KSI. What is value given for that material? I do not have to do any research because it's already done by some people and they have published the documents. I just have to take the formulas from there. Okay. Then there are some another factors which are explained in B31.3. So E is a joint efficiency factor, W is a weld factor. Okay. So based on this, the thickness of the pipe is calculated. Again, in this thickness for the safety, some safety margin already considered here in these allowable stresses. Then you add some melt tolerance, then you add the corrosion allowance, then you arrive at some pipe wall thickness. So as I said, these are the allowable stress values given here. So it is some another material, but from here we take the allowable stress values. So going back to our presentation, then again, when I say doing a wall thickness calculation, for the different material, you have to be very careful, mainly regarding the weld joint quality factor or the weld reduction factor, because it changes as per the temperature, as per the material that we will see in our detailed sessions. To prepare the PMS, PMS is a short form for the piping material specification. So the main deliverable or the main document which a piping material engineer has to prepare is a piping material specification. I will show you one example of this PMS. Also then to prepare the VMS, which is wall material specification. Because if you see the photo of a wall, yeah. So for example here, this photo, this wall has this outer body, then it has some this disc, then it has some seat rings, bonnet, stem, handwheel. Again, here you will have a lot of different components.
The
So
screen is not visible.
to all of you,
Yeah, it's shown blank.
wait a minute, I'm sharing it once again. I think there is some problem in sharing. Till now you can see the PPT, right?
No.
Just give me. I will exit from this meeting and then I will join once again. Give me a moment. Yeah. Can you guys see my screen now? Hello.
Yes. Yes,
Okay. Yeah.
yes.
Yeah. So sorry for the interruption. Yeah. So we were at this point to prepare the VMS. So as I said, the wall is a very complicated item. It contains several different parts and all those details cannot be specified in a one document, which is a PMS. That is why we have to prepare another VMS or the data sheets for each tag number of the walls. Okay. Okay. So first I'll open one of the PMS document so that you will have an idea how that document looks alike. So in a document PMS, it is the main content are the piping classes. Okay. So piping class is nothing but one of the nomenclature that for this fluid, for example, for the water, I have to use pipe class A. For the acid, I want to use pipe class B. For maybe for the oil, I want to use pipe class C. And how these pipe class A, B, C are made, they are differentiated based on for which fluid they are used. So let us take one example. So the pipe class name is 15HC. So in the PMS document like this, there will be n number of pipe classes, depending on the project. Sometimes 20 pipe classes, sometimes 50, or even I have handled the projects where we use almost more than 100 pipe classes also. So this pipe class contains the description for different piping components which are required to form a piping system. So for example, let us see one entry pipe. What is the item pipe? Lower size, maximum size, thickness. I will not use a schedule word now, maybe because few guys may not be aware of this term schedule. Dimensional standard, material, description. So let us say I want half-inch pipe. So it is nothing but so, so let us say I want to take 1-inch pipe. Okay, and I want to use it for the water service. And for water, I can use this pipe. Then this 1-inch pipe with thickness schedule access. There is another chart which shows for 1-inch schedule access what is the thickness 1 mm, 2 mm, 3 mm, 4 mm. That's another part. So this thickness, this dimensional standard to be followed, as I said in the standard codes and standard. So what should be the dimension of this pipe? What should be the outside diameter of this pipe? What are the different requirements to be followed? These are given in this standard. So the manufacturer will have to adhere to the standard. And then when I say I cannot just say I want to buy a carbon steel pipe, I have to be the specific. So which pipe is ASTM as per the ASTM standard A, and what is the designation A106 grade B, and how that pipe should be manufactured, seamless or welded. What should be the end connection? It is a plain end or the butt welded end, like this. The document contains the pipe, details of the pipe, details of the flange. So for example, this is a till 1.5 inch, we are using the socket welded flange. And from 2 inch and above, we are using weld neck flange. These flanges has to be prepared or I'll say the manufactured as per which standard ASME B 16.5. So if you buy a weld neck flange anywhere in the world, the manufacturer, if he is following this standard, so if you are building a plant in Europe and you want to procure an item from India, you can do that because a vendor from Europe and a vendor from India both are following a same global standard, which is ASME 16.5. Flange in Europe and flange in India will be exactly same. And then what is the material for that is ASTM A105. So this is also carbon steel. This is also carbon steel. But it will be called by some different designations. Then it is 150 is class 150, it is a rating. Then what is the facing? It is a raised face. So then we have a different facing, a raised face, RTJ, like this. Then this is spacer and blind. Then we also require the elbow. So 90-degree elbow, 45-degree elbow. What is the size range? Which stand? So here, this is a socket welded elbow, and this is a butt welded elbow. Okay. So for socket welded fittings are made from the forged material, which is A105, which is same as a flange. But for the bigger fitting, we use the rod fittings, which is ASTM
Hi, sir.
A234.
Hello.
Yeah.
So I'm not seeing anything being presented on the screen. Sorry. Interrupting.
Again. Oh, what? Can you see the PDF?
No. Now, yes.
Yeah, I'm sorry. Um, so you are seeing the PDF for the first time, or it was visible
Yes.
previous
This.
and
Yeah.
okay. Sorry.
Yes. I'm now seeing the PDF for the first time, sir.
Okay, okay, okay. So sorry for the inconvenience. So as I said, this is a PMS document, PMS, piping material specification, and this lists a single pipe plus example. It contains the details of the different piping components like the pipe, flange, its fittings. These are the fittings, the valves, the gasket, and the bolt. Just to give an example of this pipe, how they are specified. If I want to buy a 1-inch pipe, then it says pipe 1 inch. What should be the thickness of the pipe? It is the XS, means it has some value given in the standard there. Which standard it is the thickness value is given? It is ASME B36.10. Then what should be the material of this pipe? It should be ASTM A106 grade B. What should be the end of the pipe? It should be plain end. And how the pipe should be prepared? It should be prepared seamless. So again, I'll go to the Google. I'll say plain end pipe. Yeah. So I'll take the help of this ready-made image. So if you can see this plain end, um, it is the pipe is simply if the pipe is cut, then it will have the plain ends. You see here is a bevel end. Bevel means like see it has some edging is made so that a proper welding can be done here. So it's a bevel end. Then we also have the threaded ends. Then we have a socket spigot end. This socket spigot end you might have observed on our water pipes laid by our or maybe the sewage pipes by our municipalities. And but this we generally not use in our APC industry. We for the small size we use a plain end. For the 2-inch and above, we generally go for the bevel end. And for the nipples and something like this, or where we have to connect the instruments which has a threaded connection, there we use a threaded end connections. Now, can you see a PDF?
Yes.
Yes. Yes.
Okay, okay. So like pipe, now we have specified the flanges also. So as I said, flange is used for the connection of the piping. So yeah, okay. Let us take this example of this wall. So this, sorry, So these flanges, if I want to buy this flange, even if this is carbon steel, I cannot say give me a flange of ASTM A106. If I say ASTM A106, 105, then it will be a forged material that I know. And generally forged material is used for the flanges. So again, there are some different concepts. Like till 1.5 inch, we use the socket welded flange. Above, we use for the well neck flange. Then this is a class 150. So depending on the pressure and temperature combination. There is one standard ASME B16.5. There, one chart is given pressure temperature rating. Maybe I'll try to show you that if possible. Pressure, pressure rating. Yep. I'm not. Yeah. Is my Google page visible to you guys?
Yeah.
Yes.
Yes.
So how do we decide a rating of a flange? So how should I give the analogy of a rating? Um, okay. So I know that I want to design my piping system for, let us say, example of water. Okay. Then I know what is the pressure of that water and I know what is the temperature of that water. So and for the water I can use a carbon steel. For the carbon steel flange, which is a material A105. Obvious. How this material will be selected in the PPT, I have given you this, I have shown you this chart. Okay, can you see this chart?
Yes. Yeah.
Yes.
Yeah. So maybe I'll open a notepad just to give you a sequence. Okay. So for what I have to design my system, I have to design my system for water. Okay. I'm just saying a very common name. Okay. Okay. Now for water, which is a suitable material for water, carbon steel. Okay. Now, for carbon steel for component of flange, what is the ASTM material? It is ASTM A105. Now, how I'm checking this from this? I know carbon steel I have to use. For the flange, we use the forgings. Then it is A105. Now I know exact which ASM grade I want to use. Now I want to see the rating. Rating is nothing but the pressure taking capacity of that component. Then I will go to this chart from a standard ASME B16.5. Okay. Now can you guys see the Google screen, Google search page?
Yes. 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 We can.
Then at this 105, I know this table is applicable for this different materials. So under forging, there is A105. So if my water temperature is 250 degrees Celsius, just an example, huh? If my water temperature is 250 degrees Celsius and my pressure is 125.8 bar, I'm just taking exact figure, then it comes, this value apply, comes here. It is in which column? 900. So my flange has to be of a rating of a class 900. These values can be interpolated. For example, at 250 degrees Celsius, my pressure is 90 bar. Okay. Then from here, I will go on right side. Can I use class 150 flange for 90 bar? No, because what this table shows, my flange of class 150 is suitable at 250 degrees Celsius for 12.1 bar. If my pressure is above this, my flange is not suitable. Okay, but if my pressure is below this value, then my flange is suitable for class 150. Okay, so if I say it's a 90 degree, my pressure is 90 degree, 90 bar, then I'll go on right side. This 90 is more than 83.9, which a class 600
So,
flange can sustain. Then
so
I will
this,
select a class 900.
so the presentation is just stuck on the Google search page. It's
Yeah, yeah,
just
yeah. But can you see this chart?
there's just a wider range of charts. There's like 16 charts on the page,
Yes,
not a single.
yes. Chart is available. We can able to see.
See this chart I'm showing, the green, the, can you see this one?
Yes,
No.
yes.
Yes, we can see.
Yeah, I think everybody is able to
Everybody
see.
sings.
Okay, so this is how we select a rating of a flange. Rating. Actually, I want to give you an analogy to understand what is exactly a rating is. A rating is nothing. I'll say. Yeah, yeah. Good example. Um, when you go to a supermarket, okay, and mainly if you go to any Indian supermarket with a DMart or something, and if you want to, there is one section for the grains, loose grains like a sugar or the rice or something, and then you will find if you want to take maybe 2 kg of a sugar, okay, 2 kg of a sugar, then there is one bag which you will pick up for the 2 kg, okay. But if I want to take maybe 20 kg of a sugar, okay, then I don't have to only increase the size of the bag, but I also have to check if my bag is quite thick or not. You understood? So that thickness is nothing but show called as a rating, not exact analogy, but I'm just saying that this flange should be able to sustain this pressure at this temperature. So it is not only a pressure always. Okay, if I want to carry something in my bag, I'll say, okay, no, this will be very heavy. Otherwise, my bag will be torn out. Okay, so we always think about the weight of that component. But in a chemical plant, we don't have to only think about the pressure. We also have to think about the temperature, because as the temperature increases, the pressure sustaining capacity of a component decreases. A very fantastic example of this can be given as an iron. Okay, if you take a iron plate, if it's a cold, it's just a cold plate at a normal temperature, and if you try to bend that plate, it won't bend. But if you heat that plate, make it a red one, if you hit that plate, and if you try to bend that plate, it will bend easily. So bending iron plate, I don't know if it will get after hitting. I hope you understood what I want to say. It's like just forming. If we take some iron plate and if we just hit, then we can easily bend it. Why we can bend it? Because then it loses its strength, I will say. In proper word, it reduces its allowable stress value. So if you see, even if I take a single flange of class 150, I am not changing that flange. But if my temperature of the fluid increases, that flange can sustain a lower pressure. Can you see here? At normal temperature, at 38 degrees Celsius, which is a room temperature, if my fluid is at room temperature, my flange can sustain a pressure of 19.6 bar. But if same fluid, if I hit at 400 degrees Celsius, then my flange can sustain only 6.5 bar. So in a single statement, I will say the pressure retaining capacity of a component reduces as the temperature increases. Okay, so let's go back to the. Okay, can you guys see the PDF?
Yes, we can.
Okay. So again, I'm back on the PMS. We just one example of a pipe class. So like this, for different materials, we have to give the different ASTM grades, and then we have to specify the um, different parameters which are applicable for this component. For example, for the flange, we are specifying class 150 rating, but we don't specify class 150 for the pipe. We are specifying class 6000 for the socket welded fitting, socket welded elbow, but for the butt welded elbow, we do not specify the rating. So each component has certain parameters which have to be defined when you want to buy that component. If I want to buy a pipe, which are the things which I should tell the vendor that I want this much size pipe, 1-inch size pipe. I want 10 millimeter thickness. I want the pipe as per this standard. What should be the end connection of a pipe? It should be the plain end or the butt welded end. And how pipe should be manufactured, seamless or the welded. If I want to buy a flange, then I'll say my flange should be of class 150 rating. What should be the end connection? It should be the rest face or the RTJ. I have not covered the facing of the flanges in this session. It's not possible to cover everything, but these parameters you have to tell, like again, analogy I will give of buying a mobile phone. How much megapixel camera I need? Okay. Then what should be the screen size? What should be the memory? What should be the RAM? All these parameters we give when I want to buy a mobile. But if I want to buy a bike, then I don't tell him that I want 128 megapixel bike, because that megapixel is not applicable for the bike. Megapixel is applicable for the camera, which is used in mobile. So like this, rating is applicable for the flange, but rating is not applicable for the pipe. Why? Is to be tell in very detail. Okay. So this PM is a document which specifies the details of the different piping components. So now, as I told you about the valve, so let us take an example of a globe valve. Okay. So this globe valve to be manufactured as per the BS 187 standard. Its body should be as per ASTM 8216. So can you see the PPT once again?
Yes.
Yeah. So the wall body is made from the casting material. The bigger wall, I mean the 2-inch or more. Like the flanges are made from the forgings, fittings are made from the rod. Similarly, walls are made from the cast material. So for the carbon steel, what is the casting material? It is called as a A216 grade, different grades, but This is general grade which we use, grade WCB. So coming back to PDF, can you guys see the PDF now?
Yes, we can.
Yeah. So as I said, for the bigger size means 2 inch and above, we use a casting material for the flanges, body, then trim. But do we have only this material, only this information is sufficient to order a complicated component like a wall? Definitely not.
No.
But at the same time, we cannot specify all this detail in this document. Otherwise, for the globe wall, you will specify this much data. Again, for the gate wall, this much data. Your document will be very huge document. That is why we prepare another document which is called as a VMS, wall material specification, or sometimes we just prepare some data sheets. And the terminology changes from each company to company. But yeah, this is the general philosophy. Again, here, general philosophy till 1.5 inch is to use the socket welded end wall. Okay. Then for bigger size, we can use for the rated, that is a class 150 wall. So coming back to our presentation, yeah, can you see a presentation now?
Yes.
Yeah. So I cannot explain the PMS document in detail because PMS document cannot be explained in one shot because it contains different components and it is important to know the component. As I said, everybody knows pipe. What is pipe? But if I want to order a pipe, which parameters I need, that also we should know. So that's will be covered in our all detailed sessions. So in general, what are different activities are carried out by the piping material engineer? Prepare the line list. So in any chemical plants, you will see several number of lines going from here to there, and we have to break those lines from this line is called as A, this is called as B, this is called as a C. So lines is nothing but a name to your streets, I'll say. If you want to go from location A to location B, you say, okay, for this I will go from National Highway 60, then I will take turn, then I will go from this road, I will go from this road. So these small patches, we divide our complete route in a small patches. Similarly, the complete layout is divided into different segments, and that segment is called as a line numbers. And against line number, we have different parameters to be specified, like how I should test the pipe, whether it should be hydro tested or the numerical tested. Then what should be the test pressure of that line? How that pipe should be painted? What should be the paint code for that pipe? So all these parameters are given in a document called as a piping list. Then prepare the list of piping specialty items like a steam tap, strainer, hoses. Okay. Then to prepare the data sheets for the piping specialty items. So as I said, if I want to buy a pipe, I want to specify details. So similarly, we have a different specialty items like a steam tap, strainer, bellows, hose, and we have to specify the each and every detail. Sometimes we have to give the sketch also, how that part should be prepared. To perform the line blank thickness calculation, I will not go into detail of this. So if you want to stop the flow, some this is called as figure 8 or the line blank. Then the way we calculate the thickness of a pipe, we also have to calculate the thickness of this line blank. Why it is important? Because that thickness should sustain that pressure, otherwise it will rupture that line blank and the flow will move forward. Then at the T connection, we have the reinforcement pad. Sometimes we just puncture the pipe, and I'll show photo. Uh, Reinforcement pad. Yeah. So this is a pipe, and if I want to take a branch connection, what I will do, I will simply make a hole here and I will join a pipe. But sometimes this is not just sufficient, because when you make a hole to a pipe, you are weakening this pipe. Now I want to check whether this weakened pipe is suitable for the given temperature and pressure or not. Then I have to do the reinforcement pad calculations. Sometimes I require this additional portion which is called as a reinforcement pad. It looks like this. So this will sit around your branch pipe and it will be welded here, which gives a strength to this joint, like this. This is how it looks in actual. So this curved part is this one, and it is welded here and here. Okay. Then to develop the different welding specification, shop and field testing specification, installation and pending specification. Again, it depends from company to company. Sometimes there are different engineers for to specify the installation and pending specification, but these documents are prepared by some another engineer, another specialist, installation and pending specialist. But I should know how to read this document, because I have to apply these documents to my piping list. For example, for the carbon steel and temperature 200 degrees Celsius, which paint system I should use. So in the pending specification, it is given. Okay. To develop technical supply conditions and requirement of various piping material to make a technical recommendations. So if I want to purchase a pipe, so sometimes there are different heat treatments to be given, like a normalize or stabilization. So I define those requirements in that document. So for example, sometimes we say if my pipe is carbon steel, then it has to be normalized. Then we specify, we create a new document which is addition to the PMS, and we say whenever the material is carbon steel, you have to do a normalization. Then when vendor manufactures that component, he goes through the PMA, goes through the data sheet of that component, and then he goes through this technical supply condition, and here the vendor has to adhere to these documents. Okay. Okay, and also the main important task of the piping material engineer in many of in the companies is floating the inquiries. So again, I'll come back to the pipe. For example, in a chemical plant, I want to buy, say, 1 kilometer of a pipe. Okay. So as an engineer, I have decided to use a carbon steel pipe. I have decided to use a 10-inch carbon steel pipe of thickness 5 mm, which shall be prepared as per the ASME B36.10, which is a butt welded pipe. Now I want to buy this pipe. So how do I buy this pipe? Okay. When we want something to buy at our home, we just go to a shop vendor. We tell him, okay, give me this pipe, and then we buy it when we have to do some work at our home. But for the chemical industry, we want it on a larger site. So we give float inquiries in the market. It's nothing but the bidding. So I tell there are 5 different pipe vendors who manufacture the pipe. I'll go to all these 5 vendors and I'll say that I want 1 kilometer pipe of this requirements. This is called as a floating an inquiry. I am inquiring about this component. Then those 5 vendors will check if they can manufacture this pipe or not. Sometimes they will deviate with my requirement. For example, I say I want 5 mm pipe. Then they will say, no, we cannot give you 5 mm pipe, but we can give you 4.5 mm pipe. Then vendor never comes on the deviation of thickness, but I'm just giving you a just how they take that deviation. Then as a piping material engineer, I have to decide. I have asked him for the 5 pipe and he is giving 4.5 pipe. Can I accept this technically? So this is my duty to check whether the deviation is accepted or not. Or a few vendors will say, okay, I cannot give the carbon steel pipe, but I will give you the stainless steel pipe. Okay. Stainless steel is always better than carbon steel. But at the same time, vendor will not give me the stainless steel pipe at the cost of the carbon steel pipe. He will give me the increased cost. So even if it is technically accepted, but from cost point of view, it will make expensive. So I'll say no. I want carbon steel only. I cannot use stainless steel. Otherwise, it will increase my cost. So such deviations you have to discuss with the vendors when they come up with such deviations. And it is your responsibility to take a proper deviation, proper decision to approve or deny the deviation. So for example, if I say another vendor is saying that he will give me 4.5 of the pipe instead of 5 then I have to tell another vendor also to give me a 4.5 of pipe, because sometimes what a vendor can say, vendor will take an advantage of by lowering the requirements. When he is giving a pipe with 4.5 thickness, he is using a less material. Hence, he will give me a low price. However, another vendors who are sticking with my requirement 5 thickness, they have to use a they will have to use the more amount of the material and they will give the more price. Then I cannot select the vendor just based on the price. Then I have to be what I'll say bring all the vendor at the same level. So these kind of the deviations we have to deal with the vendors. And once out of 5, I know that 3 vendors are satisfying my criteria, then I will ask for the commercial quotation, that at what price you are giving. Then sometimes, depending on the nature of the project, client is also involved in the commercial discussions. Then they will decide to whom we have to give this order. So it is not only at the cost basis, but also at the delivery basis. If some vendor is giving me a pipe in just 3 months, but whereas some another vendor is saying no, he will deliver me a pipe after 8 months. So even that is also not suitable for me, because I cannot stop my construction. So there are so many different factors which we have to consider while selecting a proper vendor, and this is where piping material engineer plays an important role from technical point of view. For commercial selection, we have another departments. Okay, and also as a piping material engineer, we have to coordinate with different different departments, process department, instrumentation, mechanical, or also the different 3D model softwares. But those software should also be cataloged as per the PMS document. So as a piping material engineer, we have to coordinate with the 3D administrator. So a lot of things we have to coordinate with different departments to make the streamline of the project, the smooth flow of the project. As I said, this is an overview session, the responsibility of a piping material engineer, and what are the things generally a piping material engineer handles. So it is a very vast topic, a very, very vast topic. And as I said, even the experienced engineers learns so many things now and then. So we have a detailed course on this piping material engineer, where we will be teaching you. So like we have seen the different components, right? different material. So different materials we have, these different materials. Also, we have this details that which material can be used till what temperature. Okay. Then we have these different components. What should be the end connection? Where they has, how they should be specified in the piping specification. What are the different types of the wall? What are the exact uses of those walls? All the or how shall I read the course ASME B13.3 to apply those concepts in the piping material specification. For all these things, we have designed a detailed course on piping material. So for that, you guys can contact our marketing team, or even they will contact you for this. And obviously, this is a paid course. So if you guys are interested learning the intrinsic details about the piping material specification and the role of the piping material engineer, then I'll suggest you to attend that course also. Yeah. So for today, I'll close my session here. Yeah. So I would like to close my session here. And if you have any question regarding our further course, which is a paid course on piping material specification, please contact our
Sir,
marketing
can
team.
you drop in chat box concern number, mobile number?
Wait a minute. Yeah, sure. I'll put the details, or you can go to our website, and there also you can contact. But surely I will put in this chat box. Just give me a minute.
Good afternoon. Can you answer? There are some few questions on the chat box.
Yeah. Okay. So let me go through the chat box. Okay. So first question was, what is the design temperature and design pressure? Okay. Uh, so it is the pressure and the temperature at which we want to design our plant. So as I said, if I want to select a thickness of a pipe, so at what pressure and what temperature I should design those pipes or the component. I should have some values. So on the values on which this is designed, they are called the design temperature and design pressure. Or these are the highest temperature and the highest pressure will be seen by that fluid. For example, let us take an example of, again, simple water. So generally a cooling water is used in a chemical plant. So there we take the temperature of that cooling water as a 65 degrees Celsius. What does it mean by 65 degrees Celsius design temperature? It means anytime in a plant, the temperature of that water will not exceed 65 degrees Celsius. And then we also have a operating temperature. It means my design is 65, but in general, while in operating condition, what will be the temperature of my fluid? It might be 40 degrees Celsius in general. Okay. Then another question was add external pressure calculation for line vacuum condition. Yes, right. So this is very critical point to be considered when we have vacuum conditions for certain fluids. And this topic in detail will be covered in our paid course for sure. It's an important topic. Yeah. So I think these are the two main questions which are there on the screen and which I have answered. Yeah. So I hope you guys have enjoyed this session. I know this was just an overview. Getting into the details was not possible in this short time. So when we guys will meet in our detailed course, we will try to
So
cover all the
what is the
topics.
duration of that one?
Duration that we will convey you. What will exact
Okay.
duration? But at the same time, I will request the participants who are interested in this course that what are your expectation for from this course. Okay, I know what are the important things I have to tell. Okay, but at the same time, I would like to hear what are the expectation from you, or what are the topics that you want to learn from these sessions, so that I can include those topics in my presentation. It might be already included. If not, then I will try to include those topics in that session. Yeah.
Okay.
So can we conclude this session? We are almost reaching to the 2 hours session. So if nobody has any question, then we can conclude this session, and we will meet in our main detailed course of the piping specification.
I
Thank
just
you.
ask a question. It's about what are the failure modes associated with pipings and how do you manage them? Because safety of the piping system is very, very key during operation. So what are the failure modes associated with piping system? Maybe failure mechanism, the causes, and how to manage them during operation.
Say during operation, the failure which occurs during operation can be surely avoided when you design a component. But when I say I have to design again, I'll come to very basic thing. I want to select a rating of a flange. So I know the design pressure, I know the design temperature, and accordingly I will select the rating of the flange. But when I make a mistake there itself, selecting a lower rating instead of the higher rating, this will be caught when you test a system. So before commissioning of a plant, the complete plant will be tested. So there you will come to item, you will come to know that okay, you have selected the wrong rating or you have done the wrong design. But when you talk about the operational failures, I'm not sure at what exactly phenomenon you are pointing out, but there are some operational failures which cannot be taken care during the your design also. So as a piping material engineer, we have to follow all the codes and standards to design those components, and they will be used in the piping. And for sure, there are no chances of the failure during the operations.
All right. Thank you, sir.
Okay, so thank you all of you for joining this session, and looking forward to meet you in our detailed course. Okay, thank you so much. If you have
Okay.
any question, please get back to our marketing team.
Okay.
Okay, thank you. Bye bye.
Thank you.
Have a nice day. Bye.